Hello dear children, in today's class we are going to discuss the projectile motion on inclined plane. So when I say that we are going to discuss about the projectile motion inclined plane, you may get a doubt. Sir, already we covered in the last class only, why are you discussing? Yes dear children, I can say that we started in last class but we could not complete. So projectile motion and inclined plane, in that case actually, in that concept we have two cases. One is bottom to up, that is a down to up, whereas up to down. So in a previous class just we covered only one case, that is projectile motion inclined plane only, but where it is thrown from bottom to up actually. In today's class we will be discussing the projectile motion inclined plane, but whereas up to bottom, up to down actually. In that case how the time of flight is going to be, how the maximum range and how the maximum height is going to be. Okay, let us see here. So let us consider that inclined plane. So here is the inclined plane. So here is the horizontal. So that this is inclination. Okay, it is what? Inclination. The children, and theta is the angle of inclination. I repeat once here, theta is the angle of inclination. So let us say that from here that body is projected with a certain velocity u, let us say that. So that yes, it goes in a parabolic path actually. So it is a trajectory of a projectile, and this is where actually it is given a velocity u such that it is making an alpha with the inclination. Children, try to understand here. I can, this is an angle of projection, very important. This is what actually angle of inclination, but here u is the initial velocity of the projectile, whereas alpha is the angle of projection. And the children, we know that projectile motion is a two-dimensional motion, hence velocity of the projectile can be resolved into two rectangular components. For that we need to consider, we need to first decide the x-axis and y-axis. The children, in a previous class also I said that yes, the x-axis is going to be taken along the inclination so that y-axis will be perpendicular to it. Okay, so let us say this is okay, this is going to be a positive x-axis, then this is going to be negative x-axis. What about y-axis? Yes, perpendicular to this. Okay, this is going to be a y-axis. Are you able to see? Let me check. Yeah, fine. So this is going to be a positive y-axis, whereas this is going to be a negative y-axis. Is the point clear? Fine. So that then horizontal component of the velocity will be ux. Okay, and this is going to be uy. Yes, this is going to be a uy. Fine. At any point the acceleration due to gravity will be in the downward direction only. In the downward direction, at any point you can take, at any point. So here g will be in this direction. This is g. Children, try to understand, if it is theta means this is 90, this will be 90 minus theta, then this is going to be theta. This is going to be theta. So here acceleration due to gravity also a vector quantity can be resolved into two rectangular components. Okay, so one is along the horizontal axis, let us say this is gx, okay, and along this it is going to be a gy. So now let us try to write the horizontal components and the vertical components so as to have a clear idea. So children, first let us write horizontal components, and here I am writing a vertical component. So first horizontal component is going to be ux. So ux will be u sine alpha, whereas u cos alpha, whereas uy is equal to u sine alpha. Okay, and when it comes to the horizontal acceleration, so called gx. Okay, so this can be g cos theta. Okay, and here this will be ay, that is gy is equal to, it will be minus g sin theta. Here you may get one doubt, so acceleration due to gravity is always negative, right? Children, try to understand, whenever acceleration is opposing the velocity we should take it as a negative, but if the acceleration is supporting the velocity then we should take it as a positive. if you can see, this horizontal component of the acceleration is in the direction of velocity, hence velocity increases. That's what this we are taking it as gx is equal to actually g cos theta. Now children, first let us try to calculate the time period, let us say time of flight and maximum range. So here I can say that if I say one thing, you know, you may get surprised. Dear children, in the previous case where we discussed the projectile motion in inclined plane, but where the body is thrown what we can say bottom to top, in that case we got a time period and a horizontal, what we can say maximum height, right? In this case also the expressions are going to be same. Not believing, let us see here. First let us recall in a previous case whatever we got. So we got time of flight as 2u sin alpha by g cos theta. So it is nothing but what actually, this will be 2uy by, actually here a small mistake happened, so try to understand. Here gy, it is making angle theta, so that this component will be cos theta. So gy, this is going to be cos theta, excuse me, cos theta, and this is going to be a sin theta. So don't get confused. Okay, fine, I got confused, so you don't get confused. So it is going to be actually gy, just we are taking magnitude. Okay, whatever we got, maximum height, this expression already we got, maximum height we got. So there we got it as a u square sin square alpha by 2g cos theta. So this can be written as, if you can see, uy whole square by 2gy. The children, the very important thing is that in a first case, in a second case, if you can see here, this uy component gy, uy is what actually? G sin alpha. Okay na? Gy is what? G cos theta. Means vertical components remain same, whether it is a what we can say top to bottom or bottom to top. In these two cases, the vertical component of the velocity, vertical component of the acceleration gravity remain same, and here the time of flight and the maximum height reached both depend only on vertical component of the velocity, what you can say, and vertical component of the acceleration. As these two parameters remains constant, so that time of flight and as well as maximum height attained by the projectile, in this case and previous case, both remains constant. Both remains constant. Why? Because these components are same in the first case and well as today's case also. That's what time of flight and the maximum height reached are same in both cases. Then you may get a note, sir, what is there to be changed? Yes, that is what we can say range. The horizontal range will change. Why? Let me tell you here. So here, why it will change means horizontal range is what actually? So in the horizontal, the distance covered along the horizontal direction means what is a horizontal component, right? Horizontal components are different. In a previous case and today's case, horizontal components are changing and the horizontal range depends on the horizontal components, hence horizontal range will change. Now let us derive the expression for the horizontal range. So children, we know that here S is equal to uxt plus half ax t square. Here t is what? Nothing but the time of flight. So capital T will let us take. Okay. Now let us substitute here. R is equal to, in the place of ux, yes, it is a u cos alpha, and time period, yes, sorry, total time of flight 2u sin alpha by g cos theta plus half, so ax, that is g sin theta, and t square will be t square, this total square, so it is 4u square sin square alpha by g square cos square theta. So 2 ones are 2 2s are, that's fine. So here is a g cos theta. Okay, here is g square cos square theta, and sorry, g square will get cancelled. Okay, now look at it. Our idea is, let us multiply with this cos theta, divide with this cos theta. Okay, so nothing makes different. So y means g cos theta into cos will be g cos square theta. Here g cos square theta is there, that we can take as LCM. Okay, now that's fine. So now, so here it is, g cos square theta is LCM. Now if you can see in this also in a numerator, this will 2u square. So 2u square common we can take, and here is one sin alpha is there, okay, and here also we can take one sin alpha common. So it is 2u square sin alpha into what is left here, 2u square sin alpha. So it is cos alpha into cos theta plus sin alpha into sin theta. Now if you can look at this, it is in the form of cos A cos B plus sin A sin B. It is nothing but cos A minus B. So here range formula R is equal to 2u square sin alpha into cos alpha minus theta by g cos square theta. So this is a expression for a range. Then you may get one out, sir, this is also seems to be like a previous case. Small difference is there. There we got here alpha plus theta we got, but today case we got alpha minus theta. So dear children, so this is all about, of course, with today's class we completed the projectile motion and inclined plane. Dear children, in this we have two cases. Previously we discussed one case last class, and today's class we discussed, in previous case we discussed the bottom to top, but today we discuss the top to bottom here. So here one similarity is there in two cases, one constant is there. What is that here? Time of flight and a maximum height reached, both will same. Why both will same? Because in both cases vertical components are same, only the range will differ. In the previous case also we got same expression only, but small difference. R is equal to 2u square sin alpha, it was cos alpha plus theta by g cos square theta, but whereas today expression is this one, small difference is there. Okay children, so with this successfully we have completed the concept of projectile motion. In the further classes we will try to cover the numericals based on the projectile motion. Okay children, thank you so much, all the very best.